Algebra 2. We are going over 4.3 modeling with quadratic functions. Objective to model data with quadratic functions. Writing an equation of a parabola. A parabola contains the points 0, 0, -1, -2, and 1, 6. What are the equations of this parabola in standard form? Okay. Well, our equation for a parabola is y equals a of x squared plus b of x plus c. We're given these points 0, 0, -1, 1, 2, 1, 6. So this is my x value, right? My y value. So at 0, 0, we'll do it over here. Y is 0 and x is 0. Let's see. All right, so 0 squared is going to be 0 times a, which is 0. B times 0 is going to be 0. So C equals 0. Okay? Now, let's do it with -1, -2. Y, which would be -2 in this case, equals A times -1 squared plus B times -1 plus C, which was 0. Okay? You're going to get -2 equals square root of -1. You're going to get 1 times A, which will just get you A. This is -1. I almost made a mistake. Minus B equals that. Alright, can't really solve that any farther. Let's sub in for 1, 6 over here. So you're going to have 6 equals A times 1 squared plus B times 1 plus really 0. Okay? I'm going to simplify this. 6 equals A plus B. Alright? Now we can do elimination. We have 2 equations. So you really have 6 equals A plus B. Okay, with elimination, does something cancel out right away? Yes, my B's do. So I'm going to end up with 2A equals 4. Divide by 2, divide by 2, A equals 2. Okay? Now I can plug that into here. So if I plug 2 into here, 2 plus B equals 6. Minus 2, minus 2, B equals 4. Okay, with that being said, that makes it where it should be y equals 2x to the second plus 4b plus c. There is my equation of the parabola. That is my answer. Obviously, a lot of work there. Probably worth a lot of points. Okay? We'll do it one more time. Okay, once again, we have y equals ax to the second plus bx plus c. That is the equation of a parabola. Okay? We'll plug in 0, 0. And C will get 0. Okay? We plug in 1, -2. So -2 equals A times 1, which is 1 squared, equals C. We get negative 2 equals A plus B, and we know this is 0, so I'm going to leave it off. Okay? C equals 0, don't need to put it there. Okay, now let's do our other point. We have 1, -1, -4. So we're going to have -4 equals -1 A, -1 squared plus B times -1, and then C would be equal to C, which is 0. Okay, -4 equals, -1 squared is going to be 1 times A, which is going to just give me A. And that's going to give me minus B, that would be 0, so we have this. So now, we have -6, these cancel out, 2A, divide by 2, divide by 2, -3 equals A. Alright? Now let's plug it into one of the equations. Let's go with this one. So we are going to have this. We're going to plus 3. You're going to get -1 equals -B. Divide by -1. And you should get B equals 1. We have to put it back in that formula. Y equals -3 A to the second, or X to the second, plus B, which is 1, so you're going to have X, plus C. And that would be your equation for that one. Okay. Campers at Interscope Camp launch rockets on the last day of the camp. Path of rocket 1 is modeled by the equation right there of h equals -16t to the second plus 150 plus 1, where t is the time in seconds and h is the distance from the ground. The rocket E is modeled by the graph below. Which one flew higher? Well, how do we find the maximum or minimum? Because the maximum, in this case, we're going to have a maximum because we're shooting up in the air, and we're going to find out the highest point. Well, our highest point we have figured out from other sections is probably the point in which it hits its highest point. Which means we're probably going to have to go back to about a lesson or two and go to this equation, x equals -b over 2a. Alright? B is 150. Okay? And A would be -16, so we're going to get -32 down here. We divide that, and if I recall, it is 4.7. It rounds up to. Okay? So we have that now. Now we need to plug that in because x, which is actually going to be, in this case, s, or, well, it'll be t because of time. We need to find the height, which is h. Okay, so we're going to plug this in. And obviously you're going to need a calculator for this. And when you do this, you should get about 350. H should then equal 352.6, I think. Okay? That's how high it is. Okay, now let's look at our graph. We don't have to be completely accurate because, or not necessarily, maybe. We're about right here, which is probably about 580 at about 6 seconds. Okay? Which one flew higher? Well, I'd say your rocket E or 2 flew higher. Because it was 580 feet, this one only hit 352.6. Which one probably flew longer? Well, this one, it took about 4.7 to get to its hot top. That one took 6 seconds. So I'm going to say probably the one in the chart there probably flew longer. I'm going to think about the other question. Oh, what is the domain and range? Domain. On this one, domain is your x values. Do my x values ever really stop? Well, realistically, it's probably going to be 0 and 12. Because in this chart, it'll hit the ground and it won't keep going at that point, right? Okay. Now, on the other one, it'll probably be 0. And it's probably going to take about double the time to get down there, so 9.4 would be your other domain. So x is greater than, and it's less than or equal to, both of those. That'd be your domain for this one, for the chart one. This one, x would be greater than or equal to 0, and less than or equal to 12. That would be my domain file. Range. Range is going to be, on this one, y is less than or equal to 580, because nothing can go above that. It can go below that, and actually, it isn't going to go below 0. Okay? This one, it's going to be 0 is less than or equal to y, which is less, or is, y is greater than or equal to that. And then this would be 352.6 feet. Okay? And we answered both of those. Okay, this, using quadratic regression. Okay, so we want to use a calculator here probably. So, I will get that set up. Why is it not doing what I want to? Oh, we didn't go over that in class anyway. I'm not getting that to work right anyway, right now. So, there is your homework.